talking about solving compound inequalities. And for the warm-up, I want you to think of people in your class that are boys and freshmen. Okay, and you don't have to make a list of everyone, but just jot down a few names. And then make a list of all the people that are boys or freshmen. Okay, the big difference in these two lists is that I could be in the list of or, but I couldn't be in the list of and. And here's why. In order to be in the list of and, both things have to be true at the same time. You have to be a boy and you have to be a freshman. But to be in the or, I am a boy, so even though I'm not a freshman, I would still belong in this list. So for and, both things need to be true, or only one of them needs to be true. So the first thing we're going to be talking about is inequalities with the word and. And I want you to say also that right here, this inequality doesn't have the word and, but when there's no words, it's also and. And we'll work on rewriting them so you can see that. We call this a compound inequality. Compound inequalities are when you have two different statements that are true. And whenever you see the word and, that means we're dealing with an intersection. And an intersection is where both things are true. So if you look at this graph, we've got x is greater than or equal to 3. We can all graph that pretty easily, a closed circle going to the right. X is less than 7. We could all graph that one too. It would be an open circle going to the left. Now, if we have the word and, we're looking for an intersection, or where both of these things are true. So if I were to take them and move them down onto my answer, you can see if something is going to be true in both cases, it has to be shaded twice. And this is pretty easy if you look in the middle, because obviously all of this is shaded on both of the lines. The tricky part is when you're on the outside. Here I've got a line and a closed dot. Closed dots are included, so it's still going to be a closed dot, because that point is on both of the graphs. Here I've got a line and an open dot. Open dots are not included, so this point 7 was not included in both graphs. That's why it's an open dot. And this is what intersections are. We have two different inequality statements, and we're seeing where are both of them true, or another way of saying that is we're seeing where both of them are graphed.